State the exact values for all three primary trigonometric ratios for the following angles: 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. For 0 degrees and 90 degrees, consider the definitions of sine, cosine, and tangent. Sine theta equals y divided by r, cosine theta equals x over r, and tangent theta equals y over x. Based on the values of x, y, and r along the positive x-axis, corresponding to 0 degrees, and the positive y-axis, corresponding to 90 degrees. For 30 degrees and 60 degrees, consider the 30, 60, 90 triangle. Here I have an equilateral triangle with each side being 2 and each angle being 60 degrees. Splitting this down the middle, we actually then will form a 30, 60, 90 triangle. We now have the shortest side as being 1, which is half of 2. We can then use Pythagorean theorem to figure out the other side, opposite the 60 degrees, as being the square root of 3. We will then use SOHCAHTOA to figure out the trigonometric ratios using this 30, 60, 90 triangle. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. For the 45 degree angle, we'll consider the 45, 45, 90 triangle. In this case, the two legs of this triangle are 1, and the opposite angles then are 45 degrees. Using Pythagorean theorem, we can figure out that the hypotenuse of this triangle is root 2. Once again, we'll use SOHCAHTOA. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. First of all then, for sine of 0 degrees, note that along the positive x-axis, the value of y is equal to 0. This means that the value of sine theta is equal to 0 if theta equals 0 degrees. Similarly, for cosine of 0 degrees, here we're looking at the x value along the positive x-axis. Note that since y is equal to 0, the x value is exactly equal to r. This gives then a result of r over r, which is equal to 1. For tangent of 0 degrees, once again we're looking at the y value being equal to 0, giving us 0 over x, which is going to result in 0. For 90 degrees, sine of 90 degrees, once again we look at the y value. Here the r value is exactly equal to the y value, giving us sine of 90 degrees equals r over r, which is 1. For cosine, we look at the x value along the y-axis. The x value along the y-axis being 0 means that cosine of 90 degrees equals 0. For tangent of 90 degrees, here again we're looking at the x value corresponding to 0 along the positive y-axis. Note this corresponds to having 0 on the denominator, so tangent of 90 degrees is then undefined. Looking now at the 30, 60, 90 triangle, for sine of 30 degrees, the opposite side of 30 degrees is 1, and the hypotenuse is 2, giving sine 30 equals 1/2. For cosine, relative to the 30 degrees, the root 3 is the adjacent side, and again 2 is the hypotenuse, giving cosine 30 degrees equals root 3 over 2. For tangent, again looking at 30 degrees, the opposite side is 1, the adjacent side is root 3, giving 1 over root 3, or simplifying this to root 3 over 3 by rationalizing the denominator. Similarly, for 60 degrees, sine of 60 degrees corresponds to root 3, the opposite side to 60 degrees, divided by 2, the hypotenuse. For cosine, the adjacent side relative to 60 degrees is 1, and again the hypotenuse is 2, giving cosine 60 degrees equals 1/2. And for tangent of 60 degrees, the opposite side is root 3, and the adjacent side is 1, giving root 3 over 1, or simply root 3. For the 45 degrees, we're going to look at the 1, 1, root 2, or the 45, 45, 90 triangle. Sine of theta, or sine of 45 degrees, the opposite side divided by the hypotenuse, 1 over root 2, which simplifies to root 2 over 2. Same idea here for cosine 45 degrees. Here the adjacent side is also 1, divided by the hypotenuse root 2, again simplifying to root 2 over 2. And finally, for tangent of 45 degrees, the opposite and adjacent sides are both 1, giving 1 over 1, or simply tan 45 degrees equals 1.